We've been working on determining angle relationships and extending upon that by writing and solving equations to find values of variables like x and y, or some angle measurements itself. So let's take a look at a quick sample here to kind of refresh our memory. Here we've got our diagram and we have some givens marked. Based on that, can we find the measures of these 5 angles? Let me give you a moment to take a look and process your givens and see which of these 5 could you fill in. Now, when I look at this diagram, the first thing that I see is angle AFB has a measurement of 50 degrees. And AFB is made from 2 intersecting lines. Well, we know when 2 lines intersect, vertical angle pairs are formed. AFB is vertical to EFD, so this right here would have to be 50 degrees as well. And the other thing maybe you noticed is you have this notation here, and we know that denotes the symbol for right angles, and we know right angles are 90 degrees, so angle DFC is 90 degrees as well. Well, CFD being 90 degrees, and we see that we have this line here, AFD, and we know the measure of a straight angle would have to be 180 degrees. Well, we've already used up 90 here. That means the sum of these 2 angles here would have to be 90, making them complementary to each other. And we already know one angle measurement is 50 degrees, therefore the other angle measurement would have to add up to make 90, therefore that would have to be 40 degrees. So angle BFC or CFB is 40 degrees. And looking at my diagram, I'm seeing I'm getting most of the individual angles, and the last individual angle to find is AFE. And like the last one that we talked about here, AFD, that's a straight angle, 180 degrees. And so we already have used up 50 for this piece, so the difference would have to go here. So 180 minus 50, that would give us 130 degrees, because we know supplementary angles, angles that form a linear pair, right? 180 degrees. So last but not least, we need to find angle DFB. And that's made up of 2 individual angles, so their sum would be the angle measurement. Well, 90 and 40, that's another 130 degrees as well. So that's an approach that you could use to find the individual angle measurements and some sum of the angles. Of course, there are other reasons that you could have noticed. You have, if you want to look at the intersecting lines for EB and AD, you do have a pair of vertical angles here as well that you also could have used to help solve your problems. But again, as long as you stick with your rules for verticals, right angles, complementary, supplementary, linear pairs, you should have no problems finding the individual angle measurements themselves. Now, we've also talked about setting up equations and solving. So if we had a diagram that looked like this, it's a semicircle, and we know that a full circle has a total of 360 degrees. So a semicircle here would be 180 degrees. Also looking at the angle pairs that we have our straight angle, right? Here's your 180 degrees as well being used. So we could set up an equation to solve. So if it's 180 degrees total, these 2 angles would have to make that measure. So if we add them together and set them equal to 180 degrees, we should be able to solve for the variable. So we have some combining of like terms to do here on the left-hand side. We have some variables and some constants to combine. Now we can start working on solving by undoing the order of operations. So instead of adding 26, we could subtract 26 from each side. Now we have to undo the multiplication with division, so dividing by 14 on each side. And we see that x equals 11. Well, how do we know that this is correct? We're going to check it. We said that the sum should be 180. So if I take 11 and substitute in for x for each angle, their total should still be 180 degrees. So let's do that. Let's substitute it back in, right? And see if that total is 180. So if we add up those individual pieces, we've got 180 equals 180. That's a true statement. We have the right value for x based on our equation. So here's another example. We want to find all the angle measurements for our diagram. And we know that segment DF bisects angle ADB. So is there an equation that we could write to solve for x and find those angle measurements? The key comes from this, segment DF bisecting angle ADB. When we have an angle that's being bisected, we know that it should be divided into two equal pieces. So angle FDB should be equal to angle FDA. So that's how we could write an equation to solve for x. So 3x plus 10 is equal to x plus 50. Since each side is already simplified, now we're going to start working on combining like terms, right? So remember, starting with the lowest variable, undo that. So we're going to subtract x from each side. Now we're going to undo the addition. So we're going to subtract 10 from each side. We're going to undo the multiplication. So we're going to divide by 2 on each side. Therefore, x equals 20. To make sure that this is true, we're going to substitute it back into our original equation, right? To make sure it's balanced. And also, these two angle measurements should be the same because they've been bisected, right? Two equal parts. So let's see, are the angles going to be equal? Substituting the value in for x, we're going to have 60 plus 10, does that equal 20 plus 70? Or 20 plus 50, which is 70. 60 and 10 is also 70. 70 equals 70. Therefore, we have the right angle measurement for these two givens. But what about the others? So let's go back to our diagram and fill in what we know. These two angles are 70 degrees. Could we find the remaining three angles in our diagrams? ADE, BDC, and EDC. Well, if we look at our diagram, ADC, that's a straight angle, right? And straight angles have measurements of 180 degrees. So when I add these three pieces together, I should have a total of 180. I've already used up 70 and 70, 140. If I subtract that from 180, that will give me my angle measurement here, which would be 40 degrees. Now, looking at my diagram, I've got BE and AC forming the sides of my angles. And we can see that those segments intersecting, they'll form some vertical angles which we know are congruent. So if we know the measurement for angle BDC, we should also know the measurement of angle ADE, which is 40 degrees as well. Now you also could have used your straight angle BDE, right? And like we did before, the 3 should give us a total of 180, do subtraction and find the rest. Last but not least, we've got to find angle EDC. There's a couple ways we could do that. We know that these form a linear pair, or these form a linear pair having a total of 180. So if we subtract the 40, we'll end up with our angle measurement here, which would be 140. And now we have all the individual angles for our diagram. Let's take a look at another one. Here we have our diagram. We want to find the values for the variables x and y. So what do we know about the diagram? Well, your eye should be drawn to this notation here. That symbol represents a right angle, and you know right angles have a measure of 90 degrees. NSQ is 90 degrees, which is made up from angle NSP and PSQ. So the total for these two angles is 90. We have complementary angles here. So if I add those up, they should equal 90. We have an equation to help us solve for x, right? So 5x and x is 90. We have some like terms to combine. Now we have some multiplication to undo. Therefore, x is 15. Well, if x is 15, I could find each individual measurement for those two angles, but that's not what they asked for. They wanted to find the value for x. They also wanted to find the value for y. So our attention should focus on y. Now we see this expression here, 9y plus 18 for angle MSR. Is there anything else that we know about that angle? Sure. We should see that your straight line here and your straight angle NSR, right, and MSQ, those two form vertical angle pairs, right? So if this is 90 degrees, this should be 90 degrees as well. So we know right angles are 90, so 9y plus 18 should equal 90 as well. So everything's simplified on the right-hand side. We just need to undo the addition, undo the multiplication, and y equals 8. Now we want to check and make sure this is the right values. If we take our value for y and substitute into the expression, the question is, do we get back our 90 degrees like we're supposed to? So if we do that, right, 9 times 8, that's 72. 72 and 18 gives us 90. We're good to go on that. We also could do the same thing for our value for x, which I forgot to show you. If we take our value for x and substitute it into our equation, it should give us back the 90, which it does. So always when you're solving for a variable, check your solving steps by putting it back into the equation that you started. Make sure it's fully balanced before stopping and saying, yep, I'm done. All right, one more example here. Here's our diagram. And what do we know about it? We know the measure of angle ABF is 3x plus 10, and DBE is x. And ray DB is, what does that symbol mean again? That's right, it's perpendicular. So ray BD is perpendicular to ray BF. Well, what does perpendicular mean? Hopefully remember, perpendicular means that two intersecting rays form right angles. So we know more about the diagram. So if I labeled my givens, we've got right angles being 90 degrees. We can draw that in with our symbol. We have an equation I think we can solve, right? These are complementary angles, so they should equal 90. So x plus 3x plus 10 equals 90. We've got some simplifying to do, so we're going to have 4x plus 10 equals 90. We can start undoing the equation to solve for x by subtracting 10 from both sides. Then we just have to undo the multiplication, so we're going to divide by 4. It says that x is 20. Well, let's check and make sure this really is the right value of x. So we're going to substitute it back into the original equation, each place that x is. So we've got this. Okay, so we're going to have 20 and 60 and 10. That gives us back our 90. We know we're on target. All right, let's try this. We've got ray QS bisecting angle TQP. Well, what does it mean if things are bisecting? If things are bisecting, they should be divided into two equal pieces. So we should have this angle being the same as this angle. We also know that angle PQT is 60 degrees. So this entire angle here was 60. And we also know that PQS is being represented by 4x plus 14. We want to find the value for x. So to recap, we know that angle PQT was bisected, meaning PQS and SQT make up the total, and those pieces have to be the same. So if they're the same, right, this and this equals 60. So something plus itself equals 60. That means they should be the same amount. 60 divided by 2, that would be 30 degrees, right? So this is 30 degrees and that's 30 degrees. Well, if PQS is 30 degrees and it's being represented by 4x plus 14, we could write an equation to help us solve for x. So this part's already simplified. We just have to undo our order of operations to see what results. So let's undo the addition with subtraction. Then we have some multiplication to undo with division. And so x equals 4. Well, let's check and make sure that's true. So we're going to substitute it back into our expression here and make sure it's balanced, and then also double check the original equation, right? That this angle and this angle gives you your 60 degrees. So for our check, putting it back in, so we're going to have 16 and 14. Does that give you 30? It does. If this angle is 30 and this angle is 30, it gives you back to the 60 where you started from. So today we reviewed identifying different angle relationships so we can write and solve equations, solving for different variables, solving for actual angle measurements. And now it's going to be your time to do some additional practice on your own. So good luck, and as always, if you have any questions, please contact your teacher.